universe of this course. Uh, my demonstration, I have this is a snapshot, and I have my Java files. You can see the clock, detector, GUI, the scene generator, track file manager state, and this is the main function. Also, we have the tracks and the C2 framework by the University of California. So these are the files for the C2 framework. So for my demonstration, I selected an arbitrary scenario where I have two objects in the in this 10 by 10 table matrix, and each object, and I have two objects. The tool or the algorithm should be able to detect these two objects at some point. So object number 2 is going to move horizontally uh, on the main row as something like this. Okay, I don't have, it didn't work out, but basically the idea is that this object is going to move throughout this line. At the very beginning, I have no objects, and so this is kind of the output of the tool, and we'll have the grid is showing no targets. The detection has state is 0, as well as the track and detections. Okay. Uh, the very beginning, then we will have two objects in pixel 0 and pixel 1. You can see that number 9. So anything above 8 is detectable, and of course detection, track, and association have not run yet, so they have 0 state. Then in the subsequent frame, object number 2 has moved to pixel 3, leaving behind a trace which is non-detectable. You can see 9, 5, and 9. And then detection has, we have two detections on, and you can see on pixel 0 and pixel 1. Remember that this is a frame behind from what the grid is, and hence the same thing with the track. This track is probably running 2 frames behind as well. Then pixel has moved to number 3, position number 3, and then in target number 1 is still stationary, and then detection, which is running a frame behind, is saying, oh, pixel number 0 has 1 detection, plus pixel number 2 has 1 detection. And then for the first time we have a track being opened, and the reason it is only 1 track is because when the track method decided to open the track, it was when the two objects were together, and there is an arbitrary logic to say, hey, whenever I have 2 objects together, do not open multiple tracks in case it is noise. So again, it's arbitrary. And then the association is saying track 0 is associated with detection 0. That's why this is at 1 here. Okay, and now we have fast forward. Second object has moved to the very end, leaving behind a non-detectable trace, as you can see from 9 and bunch of 5, and then the last pixel has a 9, and then detection is showing detection on pixel 1, I'm sorry, pixel 0 and pixel 9, as is, and it should be. And then tracks is saying, oh, I have 2 track files, and the association say, those track files, track file 0 is associated with detector 0, and then track association also tells that track 1 is associated with detection 9. That's what we have this 9 1 equal to 1 there. Okay, so the software is working as expected. Okay, so there's some work to do on this tool. We would like to basically see more flexibility in creating more complex scenarios at the scene generator. We would like to model noise to assess track file management system performance under false alarm. We would like to expand the detection and track files definition beyond just pixel location. For example, we can include state like range and velocity so that we can make more complex decisions when at the time of opening track files. And also we can improve the output content format for better display and analysis. Okay, so we have compared two architecture styles for the track file management system, and I have found that C2 is a suitable candidate for this kind of software product, given the good matching obtained between the architecture features and the requirements from potential users that I have already discussed. Okay, and this is the reference. Okay, thank you very much.